In this video, we're going to discuss electronegativity and polarity. So electronegativity is defined as the ability of an atom in a molecule to attract the shared electrons in a covalent bond. So if we have this simple molecule here, we're talking about the atom's ability to attract the shared pair of electrons that you can see here. So we're not talking about lone pairs of electrons around one of our terminal atoms, just the bonding electrons between the two atoms that are directly bonded together. So why is electronegativity important? Well, how bonding electrons, how atoms within a molecule share their bonding electrons can affect their physical properties, such as their boiling point, the melting point of the molecule, its viscosity, solubility, and lots of others. Electronegativity is related to an atom's effective nuclear charge. The atom with the greater electronegativity will tend to pull the bonding electrons closer to it. Metals tend to have low electronegativity values, whereas nonmetals tend to have high electronegativity values. Here you can see a very simple electronegativity chart, and if you look carefully, you see that the electronegativity values, they increase from left to right across our periodic table, and they tend to decrease as we go down the periodic table. So our atoms like fluorine, oxygen, nitrogen, and chlorine, these atoms are going to have some of the highest electronegativity values, and then they decrease as we move away from those atoms. So when two atoms are directly bonded together, those bonding electrons may be shared equally, they may be shared unequally, or they may be actually transferred from one atom to the other, creating a cation and anion. So how these bonding electrons are shared depends on the difference in the electronegativities between those two atoms that are bonded together. So let's look at a few examples. So for very simple molecules consisting of only two atoms, so here we're talking about very simple molecules. More complicated molecules, we have to, with more than two atoms, we have to look at them a little differently. But for simple molecules with just two atoms, the bonding electrons are shared equally if the difference in electronegativity is between 0 and 0.4. If you have atoms with two atoms bonded together with electronegativities of 0 to 0.4, we say the bond holding them together is a non-polar covalent bond. So those electrons are not being pulled significantly towards one atom or the other, but they're shared equally. So for molecules with one bond, this molecule is also said to be polar. So we're saying the bond is nonpolar, and if there's only one bond, then the whole molecule can also be considered nonpolar. Again, for molecules with more than one bond, we have to look at some other factors as well. So we can say that the electron density is going to be distributed evenly around these molecules. So let's look at this molecule to help illustrate this, Cl2. Here you can see the dot structure for Cl2. And let's determine the difference in electronegativity. So we look on our table and we find chlorine has an electronegativity of 3.0. So we've got this chlorine has an electronegativity value of 3.0, and of course this one does as well. So let's calculate the difference in electronegativity. The difference in electronegativity between our two chlorines, 3.0 minus 3.0, of course, is 0. So the difference in electronegativity between these two atoms falls between our 0 and 0.4 range, so that tells us that this molecule is nonpolar. If we look at this picture here, we could say that for this molecule, Cl2, the electrons are shared equally around this molecule. So the electrons are not pulled towards one way or the other, they're shared equally, and therefore this is defined as what is called a nonpolar bond, and since this molecule has only one bond, this is a nonpolar molecule. Okay, so molecules, simple molecules like this, with just one bond, if the difference in electronegativity between those two atoms is 0 to 0.4, then the bond is nonpolar, making the molecule nonpolar. Okay, so let's look at another instance. Again, we're talking here about simple molecules with just two atoms, only one bond. The bonding electrons are shared unequally if the difference in electronegativity between the two atoms that are bonded together is 0.5 to 1.9. If it falls within this range, if the difference in electronegativity falls within this range, we say that those two atoms have a polar covalent bond. So for molecules with only one bond, if the bond is polar, then the molecule is polar as well. So that means that the electron density is unevenly distributed around the molecule. So polar molecules, the electrons are pulled more towards one atom and away from the other, giving the electrons an unequal distribution. They're going to be more centralized around one atom than another, giving us a polar bond and a polar molecule, again, for very simple atoms like this. So for polar molecules that have only two atoms, the region around the more electronegative atom has more electron density because those bonding electrons are pulled a little bit towards it. So we say that atom, the atom that's more electronegative, is going to have a partially negative charge, and we indicate that with the Greek letter D and the negative sign. The region around the less electronegative atom will have less electron density, therefore it will have a partially positive charge around it. We indicate that with this symbol. So let's look at an example to help illustrate this. Here we have hydrogen fluoride. These two atoms are essentially fighting over these bonding electrons. So to determine if the electrons are going to move towards one atom or the other, we look at the difference in electronegativity. We can see fluorine is 4.0, hydrogen is 2.1. So we take the difference in electronegativity between these two. And again, when you're calculating the difference in electronegativity, you always put the bigger number first and then the smaller number. That way you always end up with either 0 or a positive number. You never have a negative difference in electronegativity. Okay? So the difference in electronegativity between the fluorine and hydrogen is 1.9. Now, of course, that falls within the 0.5 to 1.9 range, telling us that this bond is polar. It tells us that these bonding electrons are being pulled more towards the fluorine. That's the more electronegative atom. So these bonding electrons are being pulled more towards the fluorine, and therefore that's going to give us a polar molecule. That's going to give us a molecule where the fluorine has a partially negative charge, not a full negative charge, but partially negative. These are not ions. This is a covalent molecule, but the fluorine has a partially negative charge because the bonding electrons are pulled more in that direction. They're pulled away from the hydrogen, giving it a partially positive charge. So therefore, this molecule can be said to be polar. This bond is a polar covalent bond. Since there's only one bond, this is also a polar molecule. So the region around the fluorine is going to have a higher density of electrons, giving it the partially negative charge, as we said, partially positive. So we're going to have electron poor region around the less electronegative atom, electron rich region around the more electronegative atom. Now also we can indicate that using this vector arrow here, which is called a net dipole moment. So let's talk about that. Polar molecules are said to have a dipole moment. A dipole moment can be given by symbolized by this symbol, this Greek letter mu, and it's a quantitative measurement of the polarity of a bond. So bonds that are very polar can have a large dipole moment, and less polar molecules can have a smaller dipole moment. And the dipole moment is equal to the charge times the distance, Q times R. And a dipole moment is typically measured in units called debays. Bond dipole moments are vector quantities, meaning they have magnitude and direction. So the electrons are being pulled in with a certain force in a given direction. And so therefore, we can represent a dipole moment with a vector arrow. So let's look back at our molecule that we had before. We could represent it that we could show that this is a polar molecule using this symbol. This is the dipole moment symbol. The arrow is pointing in the direction of the more electronegative atom, the partially negative region, and the little plus sign back here is going to be pointed in the direction or on the side of the partially positive region. So polar molecules have a dipole moment. They're said to have a dipole moment, and we can represent that using this vector arrow. Again, the arrow is always pointed towards the partially negative region of the molecule, in this case the fluorine, and it has a little plus sign at the back of it, and that is lined up with the partially positive region. So let's look at our third case. For simple molecules consisting of only two atoms, again, bonding electrons can be transferred from the less electronegative to the more electronegative atom if the difference in electronegativity is greater than 2.0. So compounds that have atoms with differences in electronegativity greater than 2.0 are said to be ionic because we have a transfer of electrons. The bond is not a polar covalent bond, it is an ionic bond, and ionic compounds generally consist of metal cations and non-metal anions because metal cations tend to have low electronegativities and non-metals have higher electronegativities. So let's look at an example, sodium chloride. Sodium, the electronegativity is 0.9, chlorine is 3.0. So if we bond these two together, let's look at the difference in electronegativity. We come up with 3.0 minus 0.9, again, always the bigger number minus the smaller number. We get 2.1. So this is greater than 2.0, indicating that the electrons are not going to be shared unequally, but will be transferred. So here you can see sodium has one valence electron. Chlorine has such a much greater, larger electronegativity that it will actually pull that electron off of sodium. It won't be shared, it will be pulled off and transferred, giving us a sodium cation and a chloride anion, and therefore an ionic compound. So just to sum up, again, here we're talking about molecules with just two atoms. We can determine that they're polar or nonpolar or ionic by looking at the difference in electronegativity between the two atoms that are bonded together. If the difference is 0 to 0.4, we say those are nonpolar molecules. They have nonpolar covalent bonds, and the electrons are shared equally. If the difference is 0.5 to 1.9, then the molecules share the bonding electrons unequally, and they have a polar covalent bond, setting up a polar molecule. And we say the electrons are shared unequally, and these can also be represented with a net dipole moment arrow. Ionic bonds have differences in electronegativity from 2 and greater, and the electron or electrons are transferred. The difference is so great that they're actually transferred from one atom to the other, giving us a full negative charge and a full positive charge, not a partially negative and partially positive, giving us a cation and anion.